Welcome to the NIZO Dairy Webcast series. My name is Raymond Kiviet, Innovation Accelerator at NIZO. We see high consumer interest in healthier, more sustainable food and nutrition. Imagine the opportunities for dairies by smarter processing, the protein transition, higher quality and safety, and the impact on health and well-being. Now, all of these will be covered in the NIZO Dairy Webcast series. Today, Professor Peter de Jong will share our view on optimal dairy processing.
Hello, my name is Peter de Jong, Principal Scientist Food Processing at NIZO and Professor Dairy Process Technology at Van Halarenstein University of Applied Sciences. For over 30 years I contribute to sustainable processing in the food industry all over the world. My keywords for sustainability are low energy consumption of your process, close to nature functionality of ingredients, and profit. Without profit, in the end, you can't be sustainable. The next couple of minutes I will show you how a smart combination of process technology and top-of-the-bill product knowledge gives you already a great start. I think I can make you happy when I could realize two things: lowering processing costs and adding more value to your processed product. To start with costs. There are a lot of unexplored measures to become more cost-effective. I will name just a few. Increasing the runtime of your equipment by decrease of fouling. Do you realize that a relatively small change of processing conditions can lead to significant runtime increase up to 50%? Another one. Improving your cleaning procedure can increase runtime by 10 to 20%. And the last example. Applying new technology to remove water, like use of membrane separation instead of evaporation. Next to reducing costs, another challenge is to add more value to your product. Dedicated processing can result in superior protein functionality, maintaining the goodness of nature. Both regarding dairy and plant protein products, we see high interest for unique product functionalities from medical, clinical, and infant formula producers. Well, I will show you some industrial examples soon. NIZO contributed to all those benefits by 4 unique values. First, as a process expert, I am surrounded by numerous product experts. We know that process optimization must meet all product quality requirements. That brings me to the next value, our modeling and data analysis skills. For more than 30 years we have been developing and validating process simulation models. These models predict process performance indicators and all types of product properties, microbial, physical, even taste and texture. Thirdly, we have the biggest food-grade semi-industrial factory in Europe, our NIZO pilot plant. And the last unique competence of NIZO is that we know what we are talking about. I mean, for decades we have optimized industrial processes all over the world. Let's move on to the industrial cases. The first one. Fouling and cleaning affect the processing costs heavily. Up to 20% of the operational costs is due to fouling and cleaning. So minimization of the amount of fouling is our start. In this example, a new recipe of infant formula caused severe fouling. The heating equipment needed to be cleaned every 2 hours. Product quality was very critical. Together with our customer, we realized to increase runtime from 2 to 12 hours with a bonus of reduced cooked off node in a new process. Thanks to Nutricia who allowed us to tell. Evaporators are complex unit operations. In projects we focus on crucial phenomena like product distribution, wetting rates of tubes, temperature time history and viscosity development during evaporation. Reducing fouling in evaporators strongly impacts energy consumption. I still remember the remark of an R&D manager from a dairy company. He said, "Your team has realized my personal year target within only 3 months." After minimization of fouling in heat exchangers, evaporators and membrane systems, we are ready for the next step, optimize cleaning. I would call this low-hanging fruit. What I see is that the effectiveness of cleaning procedures is often suboptimal. Almost all of them take too much time. An optimized cleaning starts with on-site measurements, analysis of the CIP samples, describing an optimized cleaning procedure, and ends with validation. If necessary, we apply a bypass in the CIP stream with advanced online sensors. As you can see, the annual savings are substantial, around 100,000 euros for one process line. The next industrial case is about targeted data analysis. We believe in understanding your situation and in making use of the data that's already available in the factory. When appropriate, we cooperate with students from Van Alaristan University to check the data in its context. Then a so-called clean database is constructed where process data is connected with quality data, like taste, color, shelf life. In projects, we applied data analysis to investigate causes of moisture variation in cheese. The cheese company aim was to have a higher yield and thus more profit. It turned out that the temperature of a buffer vessel was responsible to a significant part of the variation in moisture. The estimated profit was heading towards 1 million euro a year. Although this is a relatively new technique, we already run several collaboration projects this year. After one success, companies want more. Another case is on Maillard reactions in infant formula. Our predictive models enable us to evaluate a process line on product changes, starting from the raw material until the final product. This is extremely powerful. We can estimate the effect of a certain process condition on the activity of lactoferrin or alpha-lactalbumin in infant formula. Recently, NIZO and Van Alaristan University performed a big project with Friesland Campina and Vreugdeel Dairy Foods on predicting glycation in milk powders during processing and storage. Glycation is part of the Maillard reaction and is related to nutrition value. We are close to project finalization. Results confirm the possibilities of lowering the glycation rate by making just a few smart processing adjustments. My last case for today is on how new process technologies can maintain the goodies of raw materials, in this case raw milk. Last year it has been scientifically proven that raw milk has several health benefits, mainly in immunological responses in children. Pasteurization of milk destroys partly these benefits, so how to innovate on process that kills the pathogenic bacteria while maintaining goodness of nature. Computer simulations show the necessity of extreme short time and relatively high temperatures. For that reason, we came up with NIZO ISI technology, our innovation on steam injection technology. The main advantage over normal UHT heating is no holding time, making it possible to heat from 60 to 160 degrees Celsius and cooling to 60 degrees Celsius again in a split second. So the whole treatment lasts only 1 second. To illustrate the potential of this technology, we managed to make pasteurized milk with a shelf life of 60 days. Experts from dairy companies couldn't taste the difference with their own commercially pasteurized milk. At this moment, we cooperate with several parties to use this technology to pasteurize raw milk within less than 1 second. I'm looking forward to the results. If you need any additional information, please feel free to contact me. Have a nice day.
Professor Peter de Jong, thanks for sharing NIZO's vision on dairy processing. We hope you have enjoyed it, and we are looking forward to innovating together with you on your optimal dairy processes. See you at our next NIZO Dairy Webcast.